All right, folks, here's a video on another problem, fourth problem from shifted axis. It's the shifted axis day, which was yesterday's lesson. So we have this graph right here, okay? This is that, okay, which is this right here. And this is that, which is this right here. Okay, so they want, and we want it revolved around the x equals to 2 line, which is green, okay, the green vertical line essentially, okay, like that. And the area bounded between blue and pink is this orange here, okay, and we're going to revolve that, okay, we're going to revolve that around this green highlighted vertical line as stated earlier. Okay, so we're going to be basically stacking disk vertically, okay, which means we're going to do it with respect to y, which means we need it in terms of y, which means we need to isolate for x. So when you isolate pink and blue for x, you end up getting this right here. Okay, now here's the key thing to note. Okay, let me do some red dots here. Let's go right there. The radius of the blue, I hope we can agree that orange, which is the desired area, okay, the desired area is blue disk, blue minus green disk, okay? Blue disk minus green disk will give you this space in between right here and here, which is the orange space, okay, two-dimensional space, and then we're going to stack those up and down. But before we stack, let's just focus on the two-dimensional areas. So red to red, which is what we want, that's the radius of the blue, okay, all right, that's the radius of the blue. Let me see if I can get my colors a little bit more aligned over here. Okay, let's go pink on this. Pink disk minus light blue disk. Okay, how about that? Okay, just so my colors are more aligned. Now, the pink, okay, is red to red. Okay, now I like to do hypothetical numbers. Let's pretend this dot, the x coordinate was 7. Okay, 7 represents this left red to right red. But left red to right red does not represent the radius of the pink disk. The pink disk is going to be middle red, okay, is going to be middle red to right red, which is 5, which is the x coordinate minus 2, okay, all right. And the x coordinate is the same as this function right here, so we're going to need to minus 2 to get this pink radius, the radius of the pink disk. So that is why this is going to be becomes negative y squared plus 5 for your radius of pink. And we do pi r squared for the two-dimensional area of the pink disk. Now, we need to subtract out the two-dimensional area of the blue disk to get this remaining orange, okay, that's between these two vertical lines. The orange is what's desired, okay? So again, let's do hypothetical numbers, all right? Let's say, okay, let's get a whole bunch of stuff out the way now. Let's say that this is the radius that we want, okay? That's the radius that we want for the radius of the small blue disk, okay? Now, let's say this x coordinate is hypothetically 5, which it looks like it's about 5, okay? 5 represents the distance, okay, between left red and right red, okay? But that's not the distance that we want for the radius of a blue disk. We want it from middle red to right red. So we have to subtract this 2 right here. Okay, 5 minus 2 is 3. Okay, and that is the radius of the hypothetical radius of this blue disk. So whatever the x-coordinate is, in this case hypothetically a 5, we have to subtract 2. Okay, whoops, my bad. We have to subtract 2 here. Okay, and the x-coordinate is represented by this function, so we're going to subtract 2. 5 minus 2 is 3. So this whole thing right here with this bracket underneath becomes this right here for the radius of the blue. Okay, so again, let's just reiterate conceptually what we're doing. Okay, this right here is the two-dimensional area of the pink disk. Okay, whoops, pink disk. This is the two-dimensional area of the blue disk. Okay, and pink minus blue gives you the remaining orange. Okay, which is in between these two vertical lines right here. All right, pink minus blue. And then you GCF out the pi and extract the pi over here. And then you just do a whole bunch of distribution, combine like terms. So what I like to do is write out another negative y squared plus 5. Okay, write that out. Boom. Write that out here. Write out a y squared plus 3. Okay. Right here. Ignore the little 2's. Okay. And just distribute orange to orange, orange to orange, orange to orange. Remember, the pi got GCF and then extracted out the integral. So, and then combine like terms and then just do reverse power rule. Okay. With the bounds. Okay. -1 to 1. Oh, I almost forgot to talk about the bounds. Okay, when you flip your head like a confused dog, okay, let's see if I can erase all this and still have it make sense. Okay, when you flip your head like a confused dog, I swore I had the, okay. When you flip your head like a confused dog, let's go like this. Your bounds, okay, your orange bounds is going to be -1, -1. I should do orange so I color coordinate it. Is going to be -1 to +1. Okay, and what you can do is, okay, what you can do is set blue graph function equal to red graph function and solve backwards for the y values. Okay, so you can just basically set y squared plus 7 equals to y squared plus 5 and get the -1, -1, 1. But hold on, let me make sure that that's correct over there. Y squared plus 7. Oh, sorry. Y squared plus 5 equals to -y squared plus 7. I didn't see that negative that's hidden over there. Okay, that's what was tripping me out. Okay, thanks for tuning in, folks.